humans do it automatically. And I think in the future, the foundational models will as well, right? Like any problem really out there where humans do it well, but it's hard for you to describe exactly how you're doing it is a great candidate for machine learning and neural networks. But it requires a change in the architecture of how LLMs are set up today.
Hello, fellow data nerds. My guest today is Russ. Russ is the CEO of LiveKit, an open source platform powering real-time audio for applications like OpenAI's ChatGPT voice mode and Character.ai. He was previously an engineer at Twitter and 23andMe. Russ, welcome to World of DaaS.
Thanks so much, Auren. It's great to be here. I got my character hat on here.
Nice.
It's murdered out in black. A little hard to see, but
yeah, it looks
it
good,
is there.
Actually, I think I want one of those. I'm jealous.
Privilege of working with them. Yeah.
Now,
that swag.
Why is voice infra so hard? Like, what is? And there's so many companies working on it or in and around it, but why is it just so hard?
I think at a high level, it's hard because it's just a departure from the way that the typical web application works. It's just very different. So let me put it concretely. When we started to work with OpenAI, it was partially a surprise. So I built a demo at the start of 2023 that you could use WebRTC, LiveKit's kind of infrastructure that we built. It's built on top of that protocol. I built a demo where instead of texting with ChatGPT, you could talk to ChatGPT.
Yep.
And it was kind of strung together and it was a little glue and tape, but it worked pretty well and the latency was pretty low. I mean, for the standards of that time, right? Like TTS and STT they were still pretty high latency. So maybe like overall turn latency.
What's STT mean?
Oh, sorry. Yeah. So speech to text is STT and text to speech is TTS. And the way things have changed quite a bit since kind of the start of 2023, but the vast majority of voice interfaces since then that have been built where you can interact with an AI model, the original voice mode that OpenAI released, they use what we call a cascade or a component-based model. What that means is that the user says something, it streams to the back end. The audio streams to the back end where it is converted to text. So it goes through a.
And as it works, is it converting like while a person's talking? So someone talks for 30 seconds. Yeah. It's like the first 5 seconds converting while they're going, or how does that work? That's
correct. Yeah. Even the first 200 milliseconds, 300 milliseconds is being converted on the fly, and so
wow.
you're getting
and
these
it's using some of the same dynamics where like it can predict words to have a sense of like what word it might be based on what you said in the past.
So these are neural nets.
Yeah.
They're just smaller neural nets than like an LLM is, and they're kind of very tuned for the specific task. So for speech to text, it's tuned for converting audio into some kind of text-based transcription that accurately captures what the person is saying. And so it's doing that on the fly. And that's why sometimes if you talk to kind of older systems like Google, I remember Google Now, has existed for a while on Android phones. And when you would talk to it in a voice mode, you would see the translation or the transcription of what you're saying kind of changing in real time. And then eventually kind of gets finalized where the model has like a confidence level based on all of the things that you have said in the last second or two, what it most likely, the most likely sentence that you uttered. But, at every stop, like 300 milliseconds in, 800 milliseconds in, it's kind of changing sometimes or updating words within that sentence because it's not quite sure with a certain level of accuracy as to exactly what you said. And it's looking at the surrounding words all the time. In any case, so that audio is streaming in, it's getting converted into text. That text is flowing into an LLM. The LLM is spitting out tokens in a response. And as those tokens are streaming out, it's going to another neural network that is converting those tokens from text back into speech and then streaming that speech out to the user. And so this kind of stringing together of the user speaking into a transcriber, then into an LLM, then into a text to speech, and then back out to the user's device where it's played out. That's kind of called the cascaded or component model. And I think at a high level, the reason why it's challenging, even just to do this and perform well for one user, is there's a lot of variables at play. Like one is, where is the user located? Where are your models located in the world? Do you have to cross a network or a long path over a network to get the user's audio to the agent on the back end that is going to process that audio? And then you have to go through one neural network to convert it into text, and then another neural network to process that text, via the LLM, and then another neural network to convert it into speech. And you got to do all of that with as low latency as possible. And usually you're using different services. So you might be using Service X or a cloud Service X for the speech to text part, and then another LLM for the
I can see how it can get harder and harder and everything.
And then you have many concurrent conversations you're having, and so it's all real time too. So it's not like a web application where you make a request, you wait for a while, and then you get a response back. You have to have a constant connection that is going, constantly be streaming the audio, figuring out when the user is done speaking. There's a lot of kind of conversational dynamics at play here that make it quite a departure from the traditional web application paradigm.
Now, I found that when I'm talking and then I kind of a little bit ramble or or something like it messes it up somehow.
Yep.
And it's sorry, I didn't understand. And I have to re-repeat everything, which is unlike a real conversation. If I don't really know what I'm talking about in a real conversation with a human, they'll wait for me to finish. They'll be polite. They'll kind of or they might jump in and kind of help me a little bit. Oh, are going to guide me. Or if I'm searching for a word, they might jump in with something that's a normal, but the LLM doesn't really know what to do unless if I haven't really thought out what I'm going to say, it might mess up. Is that a common thing that I get afflicted with?
No, yeah, it's very common. So you're not alone in that. I think a lot of people experience that, and it's what I think is one of the hardest problems in voice AI, and what's truly holding back. It's not the only thing holding it back, but I think it's one of the key things that are holding back kind of massive or mainstream adoption of voice-based agents for interacting with services and applications like we will in the future. And that is this concept known as turn detection. What you described there, that falls under the umbrella of turn detection. Turn detection is knowing when a person is done speaking or done uttering their thoughts, but also knowing when is an appropriate time for you to interrupt, if at all, right? It might be that the right approach for that particular kind of conversation you're having with someone and the thought that they're sharing is to just wait until they're finished speaking.
Yeah. Or like I'm doing right now, ask a clarifying question or something, right?
And you just interrupt there with an or, and it felt like the appropriate time to interrupt. And I saw you interrupt, and I kind of held back and sat back and waited for you to say what you were saying. And humans kind of do.
This is so hard. Oh my gosh!
It's extremely,
I'm now appreciating how hard this is. Yeah,
it's extremely hard to do, and humans do it automatically. And I think in the future, the foundational models will as well, right? Like any problem really out there where humans do it well, but it's hard for you to describe exactly how you're doing it, is a great candidate for machine learning and neural networks. But it requires a change in the architecture of how LLMs are set up today. So to give you an example.
If you're enjoying this podcast, please sign up for our newsletter. Go to worldofdas.com. The link is in the description below. Now back to the video.
So to give you an example, there's a couple of companies out there. So QTI is a small company in France, really strong research team there, who built this model called Moshi. It's a small 7 billion parameter model. But one unique kind of part architecturally of this model is that they have this dual channel setup where audio is streaming in. And then, I'm not an expert at this either, so I'm not going to explain the full thing. But the model basically has architecturally a wiring or a connection, a connective tissue, or a joint attention mechanism, if you want to frame it in terms of like machine learning parlance, between the input channel and the output channel. And what is the net effect of that? The net effect is audio is streaming in, and the model can also optionally stream audio out. And so it can decide based on that input that is streaming in whether it should interrupt or whether it should wait, kind of in a similar way that a human does. They're kind of monitoring the inputs constantly while also thinking about what they might say at the same time. And then choosing whether dynamically, whether to insert themselves into that portion of the conversation or to wait for another moment. And if you want to see a similar approach kind of in practice, you can try the full duplex mode in Meta AI's new app. And that is this kind of dual channel thing as well. And when you go and you try it, you'll see that the actual AI or agent in Meta's app can make these dynamic decisions about whether to interrupt or not. And the latency is super low because it's not even converting to text as an intermediary for that particular application. It's processing the audio directly.
Oh, that's so
and then
cool.
and so that's the way it's going to go in the future, and it's going to be kind of widespread done this way is my guess. But we haven't gotten to the point yet where we have enough kind of audio-based conversational training data to build a large model that can do this.
Why not? I mean, you have movies, you have podcasts, you have all these different things that are out there.
You do. I think that I think what's interesting,
we might all be talking like an Aaron Sorkin movie or something or whatever.
Well, and so that's I think like to do this really well. And again, this is the non-expert, researcher perspective that I'm bringing here. But I think to do it well, you have to have a wide diversity of human to human interactions, both in group settings and one-on-one types of interactions. Because just to use an example here of what you mentioned, if you take like a podcast, like even that we're doing right now, there is a different kind of social
it's like
contract.
An interview, which is weird, right? Like this is not a normal interaction.
Exactly.
Like if we were just going to dinner, I wouldn't just be like interviewing you. We would be having more of a conversation or something.
Yeah, and if you look at the pattern, like if you were to take down if you were to look at the actual turn taking pattern in a conversation like we're having right now, it's different than two friends sitting down for coffee and just on a Friday talking about what they're going to do over the weekend. There's just a different back and forth and a different cadence to how they're talking. And so you really need like a diverse representation in your training data to be able to do this at a human level kind of accuracy.
Now, I use these voice agents quite a bit. And what I find is that it's pretty good at like one-on-one. So me and which is way better than, let's say, if I was calling for customer service, I don't want to like use the phone tree. If someone just answers immediately, "Hi, I'm Mary, 100%. The AI. Can I help you?"
Yep.
Like that's great. And I've had a few scenarios where that's just been an incredible service. Where it's a little weird is when there's more than one human on the call. Mm-hmm. Then it really doesn't know what's going on. It's kind of like, and sometimes even like my son and I will be like talking to, let's say, ChatGPT. He's interested in football. And it's like the three of us are having a conversation, two humans, one AI. And it doesn't know when to jump in. And and it doesn't even know its place. Like, should it be in listen mode? And then every once in a while, like, is it him and I having conversation? Every once in a while, it can like correct us with a new stat or throw something in, or like it's still it's super choppy.
Yeah, and so that adds another element of complexity to this problem, which is speaker diarization. So that's another issue here. Diarization. Diarization, and that is the problem or the challenge, like maybe the objective of figuring out who is actually talking in a group setting, right? Is it your son? Is it you? Is it your friend who's also there? And understanding,
and they may have just walked in the room and left.
Yeah, and then also across an entire conversational context, right? Like what's been said so far in the last 10 minutes, who has said what and labeling the correct speakers and carrying through context, right? Like your son might have said something and the AI might want to respond to that particular point that was said earlier, not something that you just said.
Mm-hmm.
And so we haven't yet seen this now because, of course, one-on-one is a much easier problem to solve. But there is going to be this future where, yeah, you have you have AIs that are attending Zoom meetings, right, for business kind of calls or things like that. Or another kind of clear example of this group dynamic that gets even more complicated is when you want to put AI NPCs in video games. And in video games, you might have multiple human players and one AI. You might have multiple NPCs and one human. You might have multiple NPCs and multiple humans. And it's like, how do you kind of work out all of those conversational quirks and dynamics such that it feels natural to interact with these characters in the video game in the same way that you might interact with a human? So it is a really hard set of problems, and we're kind of just starting to get the turn detection piece correct for one-on-one conversations. But then, yeah, we have to solve speaker diarization, and then we have to do turn detection in group settings. And so it is quite challenging. There are some companies out there that, have the data sets to potentially solve this more easily than others. Like I've been talking to friends about this, but like Zoom and Discord have just a ton of kind of multi-user conversational data, right, between many humans at once that could be used for training these models. But of course, there's security and privacy kinds of considerations there at play. But yeah, it's a hard problem to solve in terms of like the overall kind of conversational dynamics that humans have.
And where are we going in the short term, like a year from now? Like what should we expect?
I would say that a year from now, you can expect that turn detection for one-on-one is solved. I think we're definitely going to get to that point within the next 12 to 18 months. I lean more towards 12 than 18. We're starting to see this. We're starting to see a lot of progress already. Like if you look at Meta's new model, it's really impressive in how kind of conversational it is, how it can understand when to interrupt. I think another piece that comes maybe right after doing turn detection for a piece that comes after doing turn detection for one-on-one conversations without any visual input is adding visual input to the mix. So you'll notice that for turn detection, when you're talking on the phone with someone, humans still kind of mess up on sometimes they talk over each other.
You go. Oh, yeah.
Exactly. So latency is an aspect of that, right? And that's going to be embedded just in having conversations over computer networks versus having conversations in real life where the latency is almost instantaneous. So that is always going to be a somewhat of a persistent issue that we can, LiveKit can help kind of tune that down on the network propagation side or transmission side. But when you add like a video input to the mix,
you can see like right now, if people aren't watching the video, if they are, they can see me like leaning in a bit. I'm like, so you can see I'm probably going to talk then or something, right?
Exactly. There's like nonverbal cues that humans automatically pick up on that help inform whether it's time for you to talk or whether it's an appropriate time for you to interject, et cetera. And so absent that kind of visual
and also,
or
like you might have
cues,
a sense that the other person's a little bored of what you're saying. And so you might just stop talking or, so it's like all these things that are out there.
100%. And then I think another element here that I didn't talk too much about, but I think will kind of get encoded into these models with enough training data is that human conversations are self-healing. So if you start to talk over me, but then you see I continue to like speak and I almost like reject your interjection, you'll kind of back down, right? Or like another thing is...
right. Especially in a group setting. Like I want to jump in with something humorous, but then like it's hard. You can't always find the right time to jump in when you're talking with 4 or 5 people or something.
Exactly. And then I might be saying something and I might realize, oh, oops, like I wasn't supposed to say something here. And
Mm-hmm.
then you'll kind of taper off, right?
Mm.
And then like wait and then finally share your point or continue. And so it is. And these changes, by the way, are happening like we didn't talk really about latency, but like these changes are happening like within 200 milliseconds. And so that's really the threshold that, I think, yes, some turn taking can be longer, but it can get as low as 200 milliseconds. Like a human can react to these things almost immediately. And so we got to get like kind of the overall end to end down to that level to make this feel truly at the fidelity of a human to human conversation.
Interesting. And so okay, so we're gonna have the turn taking is gonna be solved essentially in the next
I
12
think
months.
I think it will be solved. Yeah, maybe it's good to like put a little bit more kind of heft around what I mean by solved. I think it will be solved to the degree that I don't think that the latency is going to get down to 200 milliseconds in the next 12 months, the full end to end. I think
What
it
is it now?
could.
Like
I'd say
when I
the
call it
vast
like a ChatGPT or something like that or whatever.
Yeah, I would say it's like, well, so for GPT 4.0, it can get as low as 300 to 320 milliseconds for the end-to-end turn latency. However, I would say it probably settles more around like the 600 or
Okay.
700 is what I would say.
And
Maybe
that's why it feels a little bit unnatural.
that's why it feels unnatural. I think like there's another component to it where that is kind of hidden underneath, which is like how long does the inference take? And I think like there's a transmission or propagation latency, which is going over our network in the ChatGPT case, and that's pretty consistent. I think the part where you see the variability comes from the speed of inference, and so that can vary widely. If you're using like a llama hosted on Cerebras, for example, you can get that latency really low. I mean, you can get it down to like 150 milliseconds. The trade-off there is like how big is the model? Like how smart is that
Yep.
model, and what's the quality of the response?
And one
So
of the
there is
problems
a
with ChatGPT is just like it just is often overwhelmed. So even if you pay for like the top eight,
yep.
like I do, it often will just like you have to reload it or it just doesn't work or something like that. Like it's super buggy on that side of things.
And
The
yeah, so
infra
that's like
still needs a lot of work. Yeah.
the variance between like the P50 and the P95 is just so wide
Yes.
that I
Yeah.
think that's what kind of contributes to that average moving up for its response speed. The so that's one part. So I think that like I think turn detection in the sense that like today how it's often annoying where you talk to ChatGPT and then like if you just wait even a moment, like let's say you use ChatGPT to practice being an interviewer with you, for a podcast, and you have the questions ahead of time. And you're going through and trying to practice how you're going to respond to things. Not doing that here, by the way, but you practice how you're going to respond to things, and then you pause for a moment to like collect your thoughts or to kind of formulate how you're going to word something, and then all of a sudden ChatGPT starts to talk to you again. I think that those like low hanging fruit of turn detection is going to be solved. I think it will start to feel quite realistic for those one-on-one cases where you're talking to a customer support agent or something like that, doing interview practice. I think it will get solved for those. I don't think we're going to have all of the speaker diarization and conversational dynamics between humans and 200 millisecond kind of back and forth or repartee between two humans. I don't think that's going to be there in 12 months, but I think within 18 to 24, it definitely could be.
Now, beyond voice, like I assume you're using a lot of like AI tools for a lot of whether it's personal things or for business. Like, what are some of the things that you're using it for that maybe like the average person isn't?
Oh, the average person. Well, the average person that can that's
Or maybe the
yeah.
average listener of this, that might be technical, but something you're doing like, is it for fun or for personal use or for business use?
Yeah, I'd say for my voice example here is really around education. So the way that I learn about new topics now is using ChatGPT Advanced Voice Mode, and I set it up while I'm on a commute or on a drive somewhere. I pop in an AirPod, and an earbud, I guess I was going to say, and I just have a conversation. I can ask this AI model like literally anything about a topic that I want to learn about,
And do
and
you think
it
about it ahead of time, like, okay, I'm going for a drive, so I kind of think about this thing ahead of time, what I want to ask, and I have a sense of the types of questions I want to ask.
sometimes, but
Because
other
I find
times
like when
it's
I do it, that's how it works. When if I'm a little bit meandering, it's harder.
so if you're meandering, it's definitely harder because of the turn
Yeah.
detection. I think like if the turn detection gets better and it gets better at like understanding how to respond to you, and we actually LiveKit, we trained a turn detection model of our own internally, and it works quite a bit better than kind of the existing, but it's not a final solution because it doesn't take into account how you're saying things, just the content of what you're saying, and in addition to the audio signal. And so it's not perfect, but it's definitely a step improvement over kind of what is existing in the ChatGPT app. The Once that gets better, I think that you'll be able to have more of a natural kind of meandering conversation where the topic you discuss with ChatGPT can be a bit more spontaneous. But I think for me, it's a mix where sometimes I know what I want to talk about going in. Like how does lightning work? And sometimes I want to talk about a top. What I'll do is I'll actually ask it, "Hey, what kind of frontier topic in science or technology can we talk about?" And like, give
Oh,
me some
that's cool.
suggestions. And then it'll be like, "Oh, well, are you up to speed on the latest in quantum computing?" And then I'll be like, "Actually, I'm not. I've never understood
Right.
qubits and how they work." And so, and we'll go deep on qubits, right? Or
That's cool.
on
Okay, I need to
and
like so almost like, hey, here's a topic. That's right. I don't. It's really about the questions, like in any good interview, coming
yeah.
up with the right questions.
Oh, so hard, so hard. We've been doing a few meetups in SF recently, and it's the first time where I've been the person on the other side who's like really doing the interviewing.
Uh,
And I have so much respect for you and other folks that are kind of in the interviewer seat because I realize asking the right questions, being like the DJ in a sense. Of this session is a lot harder than just answering
I
questions.
find
It's
I
crazy.
haven't had like a good, really long conversation with like a ChatGPT or something like that, but it's super helpful when I've got a specific thing I don't understand.
Yep.
I don't understand this thing about options trading or something, and then it could start explaining it to me, and then I can also level set it pretty quickly. I understand that piece of it, but not this piece. Or you're getting a little bit too high level. Can you get a little bit down?
Yep.
Get it more as a 12th grade level for me or something, and
Yep.
then it can level set pretty quickly and get me to the answer. But where I need
Totally.
to get much better in is getting it to help me ask better questions somehow. Like, hey, what questions would you ask? And maybe it could come up with
Ah,
some really good ones or something.
I see. Yeah, they could be definitely used for research and things like that. And I'll sometimes use it too in that way, not through voice. I'll use it through text for that. Like if I'm going to ask some questions, like this last meetup that we just did, we had Justin Uberti, who's the head of head of real time at OpenAI, and also an advisor to LiveKit, but also the creator of the WebRTC protocol, which LiveKit is built on top of. And I wanted to understand like what how can I like go deep on some of these questions based on his career and what he's done and
Uh,
places he's worked and companies he's started and kind of tying it into what he's working on now at OpenAI. And I enabled deep research and I said, hey, put together like a talk track for me. It's going to be about a half an hour talk and like what kinds of questions should I dive into or should I consider? And it was pretty good about that. But I do agree with you that one thing that is one thing that's kind of tricky is having a few back and forth and refinement, like a refinement
yeah.
process on a conversation like that. I think it's a little bit more one shot today, and I think
Especially over
in
voice, right?
especially over voice. It
Yeah.
needs to be a little bit more collaborative. And what's kind of getting in that direction is like these coding agents. So like Cursor, what my example was going to be that I don't think is like outside of the realm of folks that are listening to the show, but like I also a common AI use case for me is I use Cursor to build stuff and sometimes vibe code, sometimes like Copilot
Yeah.
on code, but I use it and Copilot, the cursor agent kind of experience is a little bit better at kind of having this multi-step going deeper and deeper on a code base and kind of starting at a high level and then drilling into certain parts. It's a bit better at that, but it also still struggles in that you have to start a completely new chat at a certain point because it kind of rabbit holes on one thing and
Yeah.
it's hard to like move it out of like some kind of local maxima and or minima. I don't know, depending on which direction you want to think about it from. But yeah,
When I
I think
watch
it is still a
people who are
weakness.
really good at using like a cursor or windsurf in like an IDE standpoint,
Yep,
or like, maybe using CSS better with like a bolt.new or a lovable or something. When I watch the people really good at that, they are iterating with like hundreds, sometimes thousands of prompts where they're asking it to change. Hey, can you please move this? Or can you move this? Or can you change this to a darker blue? Or this didn't
yep,
work out. Or now I don't understand. And it's almost like this very weird conversation over text that they're
totally.
having with this thing. And it's very strange. Like very small number of people are going to be good at this prompt back and
Yep.
forth.
Yep. I don't think that I don't think that's the long like gonna. I think that that's a bug, not a feature.
Yeah, I
I
agree.
guess is what I'm
Yeah.
saying. If you remember, like the early Dolly kind of like product, that came out or prototypes. No, not prototypes, but like beta versions of Dolly, and you had to like go and if you were really good at prompt engineering, like understanding, oh, I got to put like Nikon
Yeah,
something in
totally. Right,
here and
exactly.
like some random photographer, Ansel Adams, this, it's like,
Yeah.
these random words. And then all of a sudden it spits out something beautiful. That's maybe kind of how I conceptualize or relate like the current um, coding agent, like incantations for prompts that you have to come
And
up
also
with.
just like, it's
Like,
just, why is it all like the whole text-based thing is, I should be able to like circle your face and it's, hey, can I, make this nose a little bit differently
yep,
or change this thing
totally.
or change,
Yeah.
and it shouldn't like redo the whole thing. And ideally, like if I want just the eye color to pop, it should just make the eye color pop or something. Yeah.
100%, and that's where we're going to go. I mean, it is going to converge on Jarvis, from Iron Man, but we're not there yet. This is the early innings for that stuff too.
Where else do you think these like assistants are going to evolve over the next few years?
I think that there's gonna be two kind of paths that you're gonna see emerge. Already are emerging to a degree, but again, it's still early days for either one. I think on one side you're gonna have the co-pilot, and the co-pilot is gonna be there with you to help with creative work.
Yep.
So I'm envisioning something, like uh, I'm working on an image or a painting or something like that, or a digital painting, I guess. Maybe we'll have humanoids that also can do physical painting, but with brushes. But you're working on some piece of art, or it might be a song, it might be a movie, etc. And you are really like the director of this, and the co-pilot is helping you with some of the mundane tasks or the mechanical tasks that are kind of embedded or part of that creative work that you're doing. And so it's like, your partner in crime through that kind of experience or creative process. And we're going to see one kind of whole path of applications that are infused with AI that is your co-pilot. Not so dissimilar from like the early versions you see now with a lovable or a cursor or a windsurf. And then on the other side, and this one's a bit earlier than these copilot examples, is the autopilot examples, and I think the autopilot version of this is where it's less oriented around creative work and more oriented around kind of like mundane or rote or automatable tasks that you really don't even want to do anyway. I think human beings love to be creative. I think that
Yeah.
that's like just embedded within us as a species. I think there's other parts of work and labor that we'd all rather not do. to be honest.
Yeah,
Like,
totally. It's like
right. Like,
even like copying, go to this thing, copy the numbers from here, put it in a
yeah.
spreadsheet, send this report to this person or something like that. Like
Yeah. Does
there's
anybody
not
actually
always an
want
API for all those things, to go do
Right.
it.
Does
Yeah.
anybody actually want to do those kinds of things? And so I think in the autopilot use case, there's going to be a bunch of applications or agents, I think is like the new word that we're using to replace the word application. But the agent is the application. These agents are going to go and you can effectively tell them to do stuff for you. You can tell them what task you want them to go and tackle, and they'll go off and they'll do it. And they might ping you back and ask you for clarifications, or they might end up being blocked on something and they need your advice or guidance on how to proceed. Or they might need you to type in a password or unlock something for them or give them privileges over a resource that they don't have access to. And and that's going to be the other kind of way that you
It's
interact with this
really hard to do,
technology.
like, figure that out though. Like it's like even like a
It
very
is.
small example of my doctor. Like I got my blood test, and then he like
Yep.
takes and he doesn't do this, but someone in his office like literally takes each thing from the blood test and puts it in some sort of like essentially like a Google sheet to track it over time
Oh,
and
wow.
track these metrics over time.
Yeah.
Someone has to
Yep.
go in and literally go do it, and they have to know. And sometimes the blood test, changes what it is. So you have to know what's what and what is, and then it's got to be HIPAA compliant. So you can't like send it to OpenAI. It would have to be a local model that would live on your local things
Yep.
and stuff. And it's just
Yep.
like it sounds like it should be easy, but he's tried like 8 different services. None of them work yet, and he's worried about getting it wrong. He doesn't want to like scare his client if it's not right.
100%. There's a lot of challenges and on the security and compliance side and red tape that have to be, either uh, adjusted for or dealt with in some way. I don't want to say circumvented because that's not really a great word or doesn't connote the right kind of approach to these kinds of things. But they have to be taken into account. Some of the constraints within certain problem domains, like finance is one example, healthcare is another great example. But I think once that is navigated, right? Like I think over time, once we kind of figure out how to integrate AI into these workflows, like to use the example with your doctor taking these blood tests and looking at them over time, what it unlocks, I think, is going to be very profound in terms of value. So, very kind of directly tied to the blood test example you used. I had a blood test or a series of blood tests for my kidneys because I was working out a lot, eating way too much protein. Because that's what the internet told me to do, and you know, and I had my blood tested, and they said, oh yeah, you have like too much protein in your blood, and your kidneys aren't filtering out, and we think your kidneys are like a 70-year-old's kidneys, and
Oh my gosh.
a bunch of tests proved that I was fine and there was nothing wrong. Thankfully, knock on wood. Um, but what's interesting is that if you looked back at my blood test from when I was 25, 15 or so years ago, I was already showing a naturally higher sign of protein in the blood before I was doing any of this crazy diet or working out.
Got it. So if
And
like somehow they just realized that they could have
but
circumvented all that.
exactly, or they would have been able to contextualize what
Yeah.
I was showing at 25 with what I'm showing now at 40. But what they weren't doing, what the doctor wasn't doing, was because the doctor is a human and they just can't scale to the number of patients they have. The only time it got on their radar that this number was creeping up, or that it was already high or too high, was when it went from being like green into the yellow or whatever color they
totally,
associate
exactly.
zone.
Yeah.
And they're like, oh, wait, this is too high. But it turns out that entire range is supposed to span ages like, 0 through 70 or 80. And they're not contextualizing it to someone who's 30 or someone who's 41 or
Right.
whatever. Right. And so I think when you can add AI or computers to this mix and they have the context and they're compliant and all of that, all of a sudden you can unlock more value for patients because you can scale software better than you can scale human beings. It's not like to say a doctor isn't valuable. It's just to say that they have limited time, right? Whereas a computer doesn't eat, computer doesn't sleep, runs 24 hours and computes way faster than a human brain does. So
now on the founder front, one of the things you've been pretty vocal about is like having founders not raise until they have product market fit. Unpack
Yeah.
that a little bit for us.
So, I think that there are founders that have raised when they don't have product market fit and they've succeeded, right? So I don't think that this is like a hard and fast rule that you also always must follow or anything like that. But I think from my own experience, I tend to think of like raising money as a responsibility. My there's pension funds that invest in VC funds, right, and our LPs there, and my partner is a special needs preschool teacher, and she has her money in pension, and so I think of raising money as a serious responsibility, and I think of it as a job to bring a return on capital to the folks that are taking a bet on me.
Yep.
And so I think what's tricky for me anyway, and the way I think about raising capital and the responsibility associated with it is that if you don't have product market fit, then you don't really have an indication or a confidence that you can deliver a return. And so when you raise money before you have that confidence, it puts a lot of stress on the founder, or at least it puts a lot of stress on me in my experience, where I suddenly feel like I am kind of under the gun. And if I had the capability or capacity to be able to not raise, to experiment a bit, to find something that has at least some indication of product market fit, maybe not full blown product market fit, but some indication or signal, then I have the confidence level where I can say, okay, I'm going to start to dump gasoline on this fire or on this, small spark. And I think from a stress perspective, I think like you're just in a much better mental state as a founder. And so in the past, I've done companies where I've raised money, sometimes quite a bit of money, before I had really any idea what the company was going to do. I just wanted to start the company to be a founder, to say I was a founder of something. And
we've been
LiveKit
there.
was the first time I didn't do that, and it's worked out a lot better for me, both in terms of the company's success or progress, and in terms of my own, kind of mental state of running the company.
What other advice would you give to founders?
I would say the main piece of advice that I would give to founders is keep in mind that we don't have a lot of data points, right? Like a lot of the advice that you get as a founder is coming from a good place. It's well intentioned, but it's two things. One, it's folks that are trying to pattern match to what we've seen before. And we just don't have that many data points about what it takes to make a successful company. And then there's also a lot of other variables at play, like the market at large and like the space that you're playing in and competitive landscape and your own team and how fast or quickly you can iterate and react to what's happening in the macro that's out of your control. There's a lot of variables. And we try to come up with like some kind of mathematical equation that maps x to y, right? Like x being the inputs, or many x's, x1, x2, x3, et cetera, being the inputs, and then y being the output as to what you should do next. And I just don't think that we have that much data to say with any precision about what you should exactly do. So I would take kind of the advice that you get that is sort of pattern matchy with a grain of salt. The other thing that I think is really important for a founder to bear in mind is that nobody understands your product, your space, what you're doing better than you do. When you go into a VC pitch and you feel super nervous because these folks are investing large amounts of money and they seem like they know a lot, they actually don't know as much as you do about what you're working on, right? So they're there to learn and get up to speed.
If they do, there's a problem.
Exactly. If they do, there's a problem. I've also had founders come to me and say, "Oh, well, I'm thinking about bringing on this person as an advisor to help kind of guide the product or serve as like a product advisor, head of product." I'm like, if you need to do that, I mean, I think you're in trouble. Like, I think you
have to be the PM.
You have to be the PM. You are the number one visionary PM for what this product is going to be and where it's going. And you cannot farm that out or outsource it. And so I think that's generally is like, kind of think about advice in that way. Don't put too much stock in it. And then kind of the corollary to this is think first principles. I know it gets said a lot, but like nobody knows what the right choice is better than you will. Like incorporate learnings, incorporate that information, but make a first principles decision. Reason about it, not based on what other people do. Reason about it based on the information you have and make the best decision given what's put in front of you. And then kind of react to what you learn as a result, right? And kind of be comfortable. I think it's good to build the muscle of being comfortable with making mistakes, acknowledging that you did the best you could with the information you had, and then doing something differently now that you have more information, right? So I think that's another piece of advice I'd give.
On your X bio, you describe yourself as a late bloomer. What does that mean, and why is that?
So I think
like
I think
kind of
what's
didn't
interesting.
excel in kind of high school, college type of thing, or what do you mean by late bloomer?
Well, I think it's there's an interesting kind of juxtaposition in my career, at least that I kind of, when I look back at my career, the way that I view it is I've been pretty early to stuff, like early to some ideas. I was, in the fifth batch of YC. I was the second front end, 75th employee at Twitter. I had joined 23andMe. I interviewed there and got a job offer, but turned them down to do YC when there were 5 people. And then I went back after my YC company failed, and I went and I joined them as like the 30th or 35th employee. And so I've been like early to things, right? And I have more examples, but I won't belabor the point. But then when I've I think I've been early to things that have been done by other people. So I think like I've been good at kind of like looking and seeing what is out there, and kind of like selecting into things that I think are going to become big movements or things, big parts of the future. But then when it comes to like starting my own company, I think I've been pretty immature. And I think that it took me 5 tries to really learn kind of what responsibilities and thought process is required to be a good founder, to kind of learn some of the stuff that I just told you, like around like first principles thinking and not putting too much stock in what other people tell you or the direction other people tell you should go with your product. Thinking strategically about go to market, like how do you prioritize different product initiatives, properly, and which ones are going to be the things that in the near term you have to kind of weigh in on versus like waiting for other parts that might pan out in the long term, and kind of pushing those off despite them being these shiny objects. Knowing when to grind versus when to kind of go for the greenfield opportunities. And so I think that it took me many tries to learn that. And I don't think all of it was just from like doing startups. I think some of it was due to just like getting older and learning more things kind of, adjacent and going through life a bit more. But that's why I kind of say like, in my X bio, I talk about early, but then as a founder, I think a late bloomer for sure.
You mentioned 23andMe. Like, why wasn't that company more successful? Like, what it had so many good things going for it.
Yeah.
It had the mind share and the market share. It was early. So many people I know were customers, and millions, or maybe tens of millions of customers, and everything. It has all these ways of learning from one another. It had the founder that has billions of dollars personal net worth, and so she can like all these things you think would have made it successful. Like, why was it not successful?
I think that there's as you've done startups, of course, in the past, and I think there's a lot of different things that can contribute to a startup not working out, right? There's like 1,000 different ways you can get killed as a founder, or your company can get kind of killed. But I think fundamentally, there is one thing that, in my opinion, kind of held 23andMe back from being successful. This is something that I even I kind of said to them, or folks that work there, including Anne. She's wonderful, by the way, but yeah, including Anne. Back in the day, even after I'd left, and that was fundamentally science moves slower than technology. And so 23andMe was really early in the game at doing this kind of, personalized genomics and personalized medicine as like a goal. And I think it's a wonderful goal. Like, I think it's going to be a thing that happens. And within the next 10 years, we're going to have a lot of like the things that I think Anne and the team there envisioned in the future, even back when I was working there. And so I think timing is really important. And what's tricky is that like 23andMe came in, they're the first player, and they have all, you said like a lot of people, like have all done 23andMe, and they've kind of captured the market share. And we were Oprah's, favorite product back in 2008. And I remember packing boxes. Like we were Times, one of Time's inventions of the year, or I think Time's invention of the year in 2008 or 2009. And I remember just like being inundated with like these purchases of the spit kits, and so we were having to go and work overtime packing boxes, like the whole team. And it was great energy,
fun.
And it was a great moment. But I think that when it comes down to it, you get your DNA sequenced, and you take a look at like what we can say about your genetics today at that time. And it just wasn't that high impact except for a few individuals. So like BRCA1 with breast cancer, ApoE with Alzheimer's, LRRK2 with Parkinson's. For a very small set of those markers, genetic markers, we can say something very impactful to your life. But for the vast majority of people, we can't really say anything.
Like, okay, ApoE, like, oh, what are you going to do differently? It's just like, okay,
that's true too. Yeah,
get some exercise more.
Exactly.
I don't know. Exercise, exactly. And that's it. Like, there's no other thing.
Right. It's we don't really know how to combat those kind of things, and like some of the mitigations are kind of like Brian Johnson-esque. It's like you got to do this thing for like 40 years, and then maybe you'll ward off the Alzheimer's onset, and maybe you won't. And it's one of those things that it's really hard to commit to something like that without having like a degree of precision or confidence that it's really going to work out if you do make that investment. And so I think that for 23andMe, the big challenge was, we have the technology, we can sequence the DNA, we can do it affordably, but what we can say about what your DNA says, and the kinds of like actionable advice we can give you is still very limited. We don't know enough. Maybe we need AI to like go and analyze the full genome.
Why? Like, if we start marrying that with outcomes and marrying that with, okay, people who did these things that got this, or people who got this drug differently and stuff like that, it never got, like, the databases never got merged. And obviously you could do it you'd have to do it in an anonymous way where you protect privacy, but like it just never happened. So like, I feel like we could get there, like we could get all this, not like it has. We have the data now. Like now we just merge it in, and it's like boom. It's like I would opt into that in a second. Like I think everybody who did that would opt in.
I think that they would. I think the things that make there are some complicated dynamics at play. So like, they had the FDA thing that came down on them. They were the first company really that had to deal with, how do we work with the FDA and like bring this genomic information to light, and how do we avoid being a diagnostic tool or interpreted by the FDA as a diagnostic tool, and so there was a lot of red tape that 23andMe kind of trailblazed, and so that's one thing that slows things down. This integration of systems.
Yeah.
Okay. And so how to work with them, and like there's some fear there too. It's like, how are they going to interpret, if you're a bit cavalier about it or a bit more aggressive, are they going to interpret it in such a way that they shut everybody down? And then it's like, this is why we can't have nice things scenario, and then no genomic companies can do anything. And so I think that that's one problem. The second thing is that like, and this is kind of what I was getting at with I think the fundamental part that held back 23andMe. I'll take an example of, to use an example of what I think is a good situation or a good setup is, Elon Musk is kind of like a master of this particular sort of phasing or staging of his companies. So with Tesla, the mission is to electrify the world, right, and reduce our or eliminate our reliance on fossil fuels.
Yeah.
And the way he's going to get there is not by doing that directly. It's first he's going to make really, really nice cars that people want to buy, and then the
Expensive
money
cars too.
that
It starts and then getting cheaper.
and the money you make from that is going to fuel, almost literally, right? Like pun unintended, is going to fuel your foray into robotics and into power walls and into solar panels and then those things are going to cost money and you're going to make more money from that and get to the next stage. And I think that, that's what he's done with SpaceX too. It's not like we're going to colonize Mars, right, and become a multiplanetary species. Well, we're not going to do that straight away. We're going to take other people's payloads into space and sell satellite internet and maybe do civilian space travel and maybe replace airlines for kind of traveling around the Earth. And so there are all these kinds of things that kind of help build the company up over time, even from a revenue perspective, such that you reduce your reliance on having to raise capital, external capital, and become more self-sufficient. And I think that and you can see OpenAI is moving in this direction too, and towards their path to building AGI. And this is something that 23andMe really just didn't have fundamentally. Is I think that they thought. And this is my take from the outside. I've been out of that company I worked there from 2008 to 2009, right? So almost a couple years. And so I've been out of that for a long time. And
15 plus years, sure.
Yeah, 15 plus years. But my take from the outside is that, selling kits was, I don't know if it also a subscription. I think they moved to a subscription model, but there really wasn't this kind of organic strategic path of how to layer in value over time as the science progresses. One thing that I remember talking to them about was hey, you guys should work on your own, not saying this is a good idea because hardware is hard, but your own fitness band or your own health-based product that you can constantly monitor and layer it into your genetic information. And, kind of the direction Apple Watch is starting to take, though I would never want to compete with Apple in retrospect. But, there just wasn't a staged approach to building this business over time on your way to this ultimate mission of personalized medicine for all. And so that to me is a fundamental kind of failure.
Interesting. Now, before we started talking, you had mentioned you had some interesting coincidence or something like that. I'd love to hear it.
Oh yeah, it's not a big deal. But what's so funny on my journey, right? You asked me about being a late bloomer and stuff, and how I've kind of seen trends and interesting things happening out there, and then chosen to try to work at those companies or provide my my skills in furtherance of somebody else's mission. One of the first companies, if not the first company, that I interviewed at. When I was a bachelor, when I was doing my BS in computer science at Davis, was this company called Rapleaf.
Oh my gosh, really?
And yeah, that was my one of my first interviews, if not my first one, right out of college. And I don't think that we met. I think that I interviewed with someone there, but rightfully so. I was kind of being a jack of all trades and a master of none. Part product, part engineer, not good at any one of those two things. And so I don't blame Rapleaf for not giving me a job.
This is a live. By the way, I don't want to, but I have I had a call with you, or at least I have a call here. I don't know if it was with you or not. In February 13th, 2007, which is the super early days of it.
That was right before I did YC. Yeah.
Okay, yeah. And it was a 408 phone number. I don't want to say the phone number because it might still be your phone number.
I think my mom has that phone number now.
Oh, okay, great. Okay.
We swapped numbers. She had an unlimited data plan.
So I'm just looking at it here. So that's actually and then later on, I see we had an overview Yeah, so that's right. So that's crazy. Oh my god. So you're in my old school emails going
I
back.
am.
Yeah.
I thought it was so wild that I was coming on the show and I'm
Yeah.
like, oh my gosh, this is like
Oh yeah, so it's
I when I
a recruiter forward us to you or something.
it was a recruiter
Yeah.
or like I did I apply off like a Craigslist ad? I can't remember, but it was either a recruiter or a Craigslist ad
Yeah, it
that I had
looks like a
applied to.
recruiter forwarded to us, and then somehow I think you and I did talk. It looks like I don't have the notes. Or usually I have my notes, but I don't have the
Wow.
notes. But it looks like we did talk back in the day, 2007. That's
Uh,
awesome. This is a great
Crazy, huh?
coincidence. All right, last question we ask all of our
Yeah.
guests: what conventional
What's up?
wisdom or advice do you think is generally bad advice? And you're not allowed to say follow your passion because I feel like that's like 90% of what people say when I ask them this question.
I think, well, maybe I sort of answered it though in a different way earlier, but the conventional advice that I think is bad advice is, I guess it depends on how you interpret advice. Don't do what people tell you to just because they tell you to. I think that it's like first principles thinking. Every single person that you talk to and ask for help, well, I think most people, if you have friends that are good friends, when you ask them for help, they're well intentioned and they want
Yeah.
to help you. But again, everybody's story is different, including yours, and so advice is not going to directly apply. It's like if you go into an exam in school, like for computer science or for math, and there's going to be homework problems that are similar to the questions that are on the test, but the numbers are changed or the situation is tweaked, and you have to incorporate like your learnings from those problems, but also understand how to adapt your answer or the way you go and solve that problem to this unique situation that's put in front of you, right? Like these tweaks that have happened to the problem, and that's kind of like not a metaphor, but an analogy for how you kind of take other people's advice is to like take it for what it's worth. It's learnings from a different scenario, maybe an adjacent one or maybe a similar one, but think about incorporate that into your own thinking. Like that's don't take anybody's advice kind of uh, wholesale. Derive your own answers.
That makes a lot of sense. And it's interesting because, like, people, one of the things is that most people are really good people and they're trying to help you.
Yeah.
And so you
Yeah.
meet these people, they're evangelical about a very specific thing, meditation or
Mm-hmm.
protein or some sort of diet or a workout routine or something. And it really is because it worked for them, just like religion. Like it worked for them, so they want it. It worked for me, so therefore I'm recommending it to you.
Yep.
Or this type of way of interviewing people, or this type of
Yep.
way of running a business, whatever it is. Like I'm evangelical about it because it worked for me. But just because it works for me doesn't mean it's going to work for you or your company, because we're all in different situations. As you mentioned, we have different DNAs. Our company has different DNAs. So just like that meditation might not work for you just because it worked for me.
100%. The world is way too like life is way too high dimensional to be able to really say that like somebody's exact pattern is going to apply to you and you're going to get the same results in the end. I don't know how much time you spent in like on Reddit with like people like that do exercise, but one thing you'll notice in a lot of threads where someone that knows what they're doing when it comes to exercise or weightlifting or working out, one thing you'll notice is that in a lot of threads with like experts, true experts, is they'll say, why MMV or this is what worked for me.
Yeah,
It doesn't mean it'll work for you. And then
got it.
they'll list out, kind of what their routine is. And I think that kind of applies to really all advice is take it for what it is, right? It's an anecdote. Um, and figure out how elements of that anecdote apply to you and which ones don't apply, and then make the best decision, for yourself and your unique situation. That's what I think.
I love this. All right. Thank you, Russ Asaf, for joining us. Roll the Das. I follow you at DSA, DSA, which is an amazing X handle, which you probably only can get if you're early there.
That's right.
That was like, that's an incredible 3-letter X handle. I definitely encourage our listeners to engage with you there. This has been a ton of fun and really interesting.
Yeah, it's been wonderful to have the conversation, and I really appreciate you giving me the opportunity to come on here and asking the questions, and also just kind of really nice that you looked up that old email and we're able to connect almost 20 years later.
Crazy. Yeah.
In this capacity. Yeah.
Thanks for listening. If you haven't already done so, please subscribe to World of DaaS wherever you consume your podcasts, YouTube, Apple, Spotify, and more. And please help us get discovered by leaving a review. And check out worldofdaas.com. That's worldofdaas, DAAS.com. And of course, connect with me on Twitter @Auren, that's AUREN. Would absolutely love to hear from you.